Hi, I'm Fabian. I'm going to talk about our work on automatically updating and maintaining digital street maps. Maintaining digital maps is tedious and costly. Companies like Google and Apple spend hundreds of millions of dollars annually on keeping their map data up to date. Even with this spending, though, digital maps are far from perfect. Here's an example from Google Maps, where a new residential district was constructed in 2019, but over a year later, the map has still not been updated. To improve digital maps, over the last 2 decades, there's been a lot of interest in leveraging GPS trajectory data and, more recently, aerial and satellite imagery to automatically keep maps up to date. However, most prior work focuses on map extraction, where given an aerial image, they infer the positions of all roads in that image. But there's something missing here, and that's the existing map data. In practice, we have very accurate maps in most parts of the world. So rather than using automated methods to infer entirely new low-quality maps from scratch, what we really want to do is to use them to help us keep our existing high-quality map data up to date with changes in the physical road network. In this example here, we already have a very accurate existing map covering this region, but it's just not quite up to date with the changes that happened recently between 2012 and 2019. And so to reduce the cost of maintaining digital maps, we need a method that can update our existing map to reflect these changes. But prior work is not designed for this task. Instead, prior work is designed to detect all roads in an aerial image, but it's not clear how to go from detecting roads to actually updating an existing map without introducing errors. We might employ a fusing strategy where we give the method the most recent aerial image, they extract a road network from that image, that's the inferred map here, and then we fuse those roads in the inferred map that are missing from the existing map into the existing map, and thereby derive an updated map that's the fused map at the bottom. But this doesn't perform well at all. After filtering the inferred roads for only the detections that are already present in the existing map, what we're left with is mostly false positives, because while most detected roads were correct, most of them are also already in the map. In some sense, we have a needle in the haystack problem where we're trying to identify a very small number of changes in the physical road network across a vast space. Here's some examples of false positives. Typically, they correspond to curvilinear features visible in the imagery that are not roads, like runways and walkways. To directly tackle the problem of keeping maps up to date with changes in physical road networks, we developed a novel two-stage pipeline that, rather than process a single satellite image, leverages the progression of satellite imagery over time. A key element of our approach is that we require no labels beyond those that are already present in the existing digital map. In the first stage, we independently process old and new imagery at a location through machine learning models, and then compare the outputs of those models to identify candidate areas where the physical road network may have changed. In the second stage, we further improve precision by pruning candidates using a classifier that's trained using a novel self-supervisory learning signal that does not require any hand labeling. The final outputs are proposed changes that have high precision. We evaluated our method against 3 baselines on over 3,000 square kilometers of satellite imagery. Here we show precision recall curves where points further to the right and the top are better. Our approach, the red line, outperforms all of the baselines, providing the level of precision needed for full automation to be a realistic option. Here's some qualitative outputs. Our approach generally captures road network changes with high accuracy, but there is still room for improvement, and we show a couple errors in the bottom right. To summarize, there's been a lot of work in map extraction, that is, detecting roads in satellite imagery. But for these methods to be practical, we need to go a step further and actually update existing maps. Our method robustly updates maps by leveraging the progression of satellite imagery over time, thereby reducing error rates substantially over prior work. Please check out our project webpage where our code, data, and paper are available at this URL. Thanks.